Hello everyone, today I will discuss a previous year problem of JAM 2025. This is also a problem of thermodynamics that says in a two-level atomic system, the excited state is 0.2 eV above the ground state. Considering Maxwell-Boltzmann distribution, the temperature at which 2% of the atoms will be in the excited state is dash Kelvin up to 2 decimal places. Look, this is another example of NET type questions whose answer should be up to 2 decimal places. Remember this, okay? And here Boltzmann constant Kv is given in eV per K unit, okay? So here given two-level atomic system, okay? So and the excited state is 0.2 eV above the ground state. So our delta E, the energy gap, is given 0.2 eV. Okay, there is two level atomic system. The energy gap delta E. Okay, now consider at ground state the number of particles is N1 and at excited state the number of particles is N2 and total number of particles is N. Okay, N is total number of atoms in the system. Okay, so N0 is total number of atoms in the system. Okay, so according to Maxwell-Boltzmann distribution, we can write this in 1 equals to N0 e to the power minus E1 by kT and N2 equals to N0 e to the power minus E2 by kT. Now calculate N1 by N2. N1 by N2 will be e to the power minus E1 by kT and E to the power minus E2 by kT. Calculating this, we will get e to the power minus delta E by kT. Okay. Now, it is said that the temperature, calculate the temperature, we have to calculate the temperature at which 2% of the atoms will be in the excited state. 2% of the atoms means 2% of the total atoms of the system will be in the excited state. Okay, so N2 should be 2% of total atoms. Okay, so rest atom will be at ground state as the two-level atomic system is given here. Okay, means N0 is N1 plus N2 as two-level atomic system is given. Okay, so N1, the rest percentage of the particle should be at ground state. So N1 will be 98 by 100 N0. Now put the value of N1 and N2 at this equation. We will get here will be plus sign. So delta E by kT will be ln N1 by N2, that is 98 by 2, that is ln 49. Okay, now calculate T. T will be delta E by K into ln 49. Put all the values. Delta E is given as 0.2 electron volt. K is given 8.62 into 10 to the power minus 5 into ln 49 Kelvin. After calculating this, we will get the value that will be 596.169 Kelvin. But our answer should be up to 2 decimal places. So our answer will be 596.17 Kelvin. So our desired answer will be 596.17 Kelvin.